Hi guys, good morning. I hope you had a great spring break. Today we are going to be talking about solving quadratics using square roots. So remember, to solve an equation, you're just looking for what x would have to equal. But before we get into that, let's just review a little bit with our square roots. So remember that the square root of 4, I'm going to change colors really quickly, is equal to 2. I can change colors. Not wanting to let me. Okay, here we go. The square root of 4 is equal to 2. And again, remember that is because 4 is equal to 2 times 2. And under a square root, if I have two numbers the same, it's going to be equal to one of those. Square root of 16 is equal to 4. Square root of 25 is equal to 5 because 5 times 5 is 25. And the square root of 100 is 10. So let's just remind ourselves what happens when it's not a perfect square that we have under the square root. So the square root of 20 is not a perfect square. There's no number that I multiply by itself to give me 20. So in this case, I have to break that down. So I could start anywhere, any two numbers that multiply to 20. So I'm going to go with 2 times 10. And then remember, we're going to circle the prime numbers. So 2 is a prime number, 10 is 2 times 5, and those are both prime numbers. Since 2 happens twice underneath, we can bring out a 2. But the 5 would have to stay inside because there is no match for that. So this would be square root of 20 in its simplified exact form would be 2 square roots of 5. So this is, we don't want to change it to a decimal. We want to know the exact answer. So 50 would be 5 times 10. 5 is prime, so I'm going to circle that. 10 is 2 times 5, and then I have those two 5s underneath. And the 2 would need to stay under in that one. So that would be the exact form. So we're going to use this in our solving quadratics. In order to solve a quadratic by using the square root method, we need to first solve for the squared term. So what that means is that we want to get this x squared all by itself on one side. So the purpose of solving an equation is to find which x values would make it true. So which x values could I put in here for x that would actually make it equal 0? In order to do that, I'm going to be solving, trying to get x all alone on one side, just like I normally would. So here, in order to get x squared all by itself, I have a times 3 and a minus 75. I need to undo both of those. Remember, we always undo the plus or minus first when we're solving. So I'm going to add 75 to both sides. So that one goes to 0, and I have 3x squared equals 75. And then divide both sides by the 3. We get x squared alone. 75 divided by 3 is equal to 25. So I've done step 1. I solved for the squared term. The second thing I want to do is take the square root of each side. I'm trying to get rid of this squared, and the opposite of squaring is taking the square root, right? So I'm going to take the square root of both sides. The square and the square root are going to cancel one another out, so I'm just left with x on this side. The square root of 25 is equal to 5. However, whenever we're solving for a variable that's squared, we have to think about all of the options that could equal 25 when I square it. So certainly 5 works because 5 squared is equal to 25. 5 times 5 is 25. But the other number that will actually work here is negative 5, because negative 5 times negative 5 is also a positive 25. So whenever you have a variable squared and you're looking for what value would make this equation true, we have to take the positive and the negative of that value because both will give us that result. So anytime you're solving a quadratic, there should be two solutions. That exponent right there actually tells me how many solutions there should be. So anytime you're solving a quadratic, remember a quadratic just has an x squared in it, there will be two solutions. And whenever we're doing the square root method and we're just looking for the x value, that has been squared, we'll just take the positive and the negative of whatever our solution is. So let's try another one. So solve by taking square roots, leave your answer in exact form. So that just means the exact form, that just means we're not going to be changing this to a decimal. We're going to be simplifying our square roots. If it's a perfect square, it will just give us the number like we did in the previous example. If it's not a perfect square, we'll have to simplify like we did on our second slide. So the first thing we want to do, first step, same as last time, is we want to get x squared all by itself. So we need to undo this times 2 we have here first. So let's divide both sides by 2. That will give me x squared equals 8. So that's step 1, get x squared by itself. Step 2, take the square root of both sides so that those will cancel. And remember, we're going to have a positive and a negative of whatever our solution is here. So I could write it as positive square root of 8, comma, negative square root of 8. It's just a little bit faster just to put a plus or minus in front. That just means the same thing. It means we have two solutions. One's positive of this number, and one is a negative of this number. Now 8 is not a perfect square, but I can simplify this a little bit more by breaking it down. 8 is 2 times 4, and 4 is 2 times 2. So for these two 2's underneath, I can bring one out. For the other 2 that doesn't have a match, I would have to leave it underneath. I still have a positive and a negative of this solution. So x equals plus or minus 2 roots of 2. Now I could also write this as x equals 2 square roots of 2, comma, negative 2 square roots of 2, or x equals 2 square roots of 2 and x equals negative 2 square roots of 2. Either one works. This is just a little bit faster, just to throw that plus or minus in front. And that's all it means, is that there's a negative and positive of that solution. All right, so again, first step, we want to get x squared all by itself. So the first thing we undo is this plus 1 by subtracting 1 from each side. So 7x squared equals 28. Divide both sides by 7. So now x squared is all by itself. 28 divided by 7 is 4. So now we can take the square root. The square root of 4 is equal to 2, and it could be a positive 2 or a negative 2, since 2 times 2 is 4, and also negative 2 times negative 2 is 4. All right, so this one looks just a little bit different. We have these parentheses here. We have a minus 2 on the inside. We still want to get the squared term by itself, but in this case, the squared term is everything in the parentheses. So we're first going to start by getting the x minus 2 squared all by itself on one side. So right now it's multiplied by 1/2 or divided by 2. Multiplying by 1/2 is the same as dividing by 2. So I need to undo divided by 2. So I'm going to multiply both sides by 2. Or I can think of this fraction, or I can think of multiplying by the reciprocal of the fraction, because 2 over 1 times 1 over 2 will just go to 1. But I need to do that to this side also, right? So I have x minus 2 squared equals 50, or 50 divided by 1, which is just 50. Now the squared term is by itself. I cannot undo this this minus 2, until I deal with this squared. I have to take the square root first, because the square is happening to this whole thing, this x minus 2. So before I can add the 2 to make this go away, I have to get rid of the squared. So those two will cancel each other out, and I'm left with x minus 2 equals plus or minus the square root of 50. So remember, it could be positive square root of 50 or negative square root of 50. 50 is not a perfect square, but I can simplify that a little bit. That would be 5 times 10, and 10 is 2 times 5. So I have 2 5s, which means I can bring out 1 5. The 2 would have to stay underneath. Still have a plus or minus here. So I have x minus 2 equals plus or minus 5 square roots of 2. Now in this case, x is still not by itself. I still have this minus 2 that I need to add over. So I'm going to go ahead and do that. But before I do, I'm going to actually break this up. I'm going to put one solution, the positive 5 square root of 2, in one equation. And I'm going to put the negative 5 square roots of 2 on the other side. So now I'm going to finish these off by adding 2 to both sides. And if I add 2 to both sides here, so on one side I have 5 square roots of 2 plus 2, and on the other side I have negative 5 square roots of 2 plus 2. Doesn't really matter whether I put the 2 first here or the other. And in this case, I guess I could have just written it as plus or minus 5 roots of 2 plus 2. That would have worked. But sometimes this will simplify to a whole number, and then we can actually go ahead and add the 2. But because these are not considered like terms, because this one has a times square root of 2, I can't actually add these together, so I have to leave my answer like that. All right, 1/2 times x plus 3 squared equals 8. So again, I need to undo this times 1/2 or divided by 2. Remember, timesing by 1/2 is the same as dividing by 2. So I need to multiply both sides by 2 or by 2 over 1. And that will get rid of that. So I'll have x plus 3 squared equals 16. Now remember, I need to undo the squared before I can get to this plus 3 on the inside to do anything about that. So take the square root of both sides, and I'm left with x plus 3 equals 4. Nope, plus or minus 4. So again, remember when you're here, break this into 2 equations because we're not done solving here. We do have this plus or minus. So I know that x plus 3 could be positive 4, or x plus 3 could be negative 4. And then just go ahead and finish solving. Oops, we want to subtract 3 from both sides here, so x would be equal to 1. And subtract 3 here, so x is equal to negative 7. So on that one, it's definitely a good idea to break it into 2 different equations because we can actually add 4 and negative 3, or negative 4 and negative 3. We get 2 different answers. All right, so on this one, we have a 4 plus out front. We still want to get this squared term all by itself first. This 4 is added on, so in order to undo add 4, we're going to subtract 4 from both sides. So I have x minus 2 squared equals negative 20. So now I'm going to take the square root to get rid of that squared, but notice this side has a negative under the square root. Remember, if I have a negative under my square root, that means that this is going to be imaginary. So I'm going to put my plus or minus out front because it could be either positive or negative square root of 20. I'm also going to pull out an I because I know this is going to be imaginary. 20 broken down, that would be 2 times 10. And 10 is 2 times 5. Since there are 2 2's underneath, I'll bring that 2 out and I'll multiply it by the I out front. And the 5 will have to stay under the root. And then I have x minus 2 on this side still, so I still need to add that 2 over. Now my answer here, plus or minus 2i roots of 5, or my right side of the equation, there's no way I can add 2 to that. And so this time, I'm not going to break it into 2 equations. I'm just going to leave it like this. It still means the same thing as positive 2i roots of 5 plus 2 as one solution, and then the second solution is negative 2i roots of 5 plus 2. But I don't need to rewrite it as 2 separate ones on this one because I can't actually combine the 2 at this point. So I still can see that it's 2 solutions, but I'm not going to break them apart to solve like I did before because this didn't come out to a whole number or like just a regular number. It came out with an imaginary number with a root still here. So that's why I don't need to really bother separating them. If it did come out as a whole number, I'd want to separate them so I could get those 2 separate solutions. So last example, actually I think we have one more that's a story problem, but let's see. So again, I want to get x minus 3 squared all by itself. Right now it's multiplied by 3, and so I need to undo multiplied by 3, which leaves me with x minus 3 squared equals negative 25. Again, I'm taking the square root here of a negative number, so x minus 3 is equal to plus or minus 5i, right? The square root of 25 is 5. because I'm taking the square root of a variable, I know I could have the positive or the negative of this number. And because of the negative underneath, I know it's imaginary. So it would just be I. Remember, 25 is 5 times 5. So there would just be a 5 that comes out. Nothing left underneath. And when there's nothing left underneath, the root part goes away. Since I can't add an I number to a regular number, again, I can just leave this as one problem and say it's plus or minus 5i plus 3. I don't need to necessarily write it separately, but you certainly could write it separately also. You could write it like this, means the same thing. But there are two solutions, 5i plus 3 and negative 5i plus 3. Let's see if we can get it to advance. All right, so little story problem. When an object is dropped, its height, h, can be determined after t seconds. So in our equation here, h is the height of the object and t is the time it takes to fall. Let's see, so can be determined after t seconds by using the falling object model h equals negative 16t squared plus s, where s is the initial height. So s is where it started out. So if I dropped it from 10 feet, it would be 10, whereas h is the final, or the height of the object at time t. So maybe like after, if I dropped it from a height of 10 feet, maybe after 1 second, it's down to 8 feet or something. Find the time it takes an object to hit the ground when it is dropped from a height of s feet. And in this case, s equals 90. So what we're going to do is we're going to take our equation here and we're going to replace s with 90. Negative 16t squared plus 90. So if we dropped it from 90, I guess 90 feet here, we want to know how long it will take to hit the ground. So when something hits the ground, what's its height? Its height would be 0, right, once it hits the ground. So we want to find out how long it took to go from 90 feet to 0 feet. So that's why I'm putting a 0 here where h is, because it's asking us to find the time it takes to hit the ground. And if it hits the ground, that means it's got 0 feet height. So now we just need to go ahead and solve for t. So we're going to subtract 90 from both sides. So negative 90 equals negative 16t squared. Divide both sides by negative 16. Now in this case, since we're doing a story problem and we want to estimate t, even though 60 does not go evenly into 16 does not go evenly into 90, we still would like, or this time we're not going to keep it as an exact answer, we're actually going to go ahead and divide. And that would give me, since I'm dividing a negative by a negative, that would give me 5.625 equals t squared. Just went ahead and divided negative 90 by negative 16. Again, even though we don't want to usually round to a decimal in some of those other problems when it said to keep it in exact form, since we're working with a story problem here and we actually want to know the approximation of how much time it would take, we are going to go ahead and round this to a decimal. When I take the square root of both sides, I'm going to get the square root of 5.625, which is 2.37. I'm rounding off to 2 decimal places. Now we know it could be positive or negative 2.37, but because in the context of our problem, if time is passing, we know it's going to be a positive number. We're just going to look at the positive answer here. So it would be 2.37 seconds. Oops. So again, when we solve, it could be positive 2.37 or negative 2.37, just like it was in all of our other problems. But because we're actually using or taking it in context of the problem, we know it would have to be the positive 2.37. All right, guys, good luck. If you have any questions, just email me. Let me know how I can help. Bye.